The following is an Encore presentation of Everything Everywhere Daily.
Once every 450,000 years or so, the Earth undergoes a radical transformation. The planet's magnetic field will literally flip. The North Pole becomes the South Pole, and vice versa. Despite the fact that we know this has happened many times in the Earth's history, we really don't know what would happen if the poles were to reverse today. Learn more about when the Earth's magnetic poles reverse on this episode of Everything Everywhere Daily. This episode is sponsored by Quince. You've heard me talk several times now about Quince and how I've gotten some great items for my home, like my Turkish bath towels and my fisherman's blanket. Quince has must-haves like Mongolian cashmere sweaters from $50, iconic 100% leather jackets, and comfortable pants for every occasion. With Quince, I can get high-end versatile pieces at prices I can actually afford. All Quince items are priced 50 to 80% less than similar brands. By partnering directly with top factories, Quince cuts out the cost of the middleman and passes the savings on to you. And Quince only works with factories that use safe, ethical, and responsible manufacturing practices, along with premium fabrics and finishes. Indulge in affordable luxury. Go to quince.com/daily for free shipping on your order and 365-day returns. That's QUINCE.com/daily to get free shipping and 365-day returns. Once again, quince.com/daily. This episode is sponsored by Up First. Breaking news is broken. You're constantly doom scrolling on Facebook, Twitter, or TikTok to get the latest updates so you don't miss anything. If this sounds like you, I recommend that you listen to the Up First podcast by NPR. Up First provides the top 3 news stories to start your day. With digestible 10 to 15 minute episodes, which is about the length of this podcast, it's all the news you need so you can get back to your life feeling informed while letting you get ready, make breakfast, or go to work. From politics to economics and both national and international news, Up First is the go-to daily habit for the news consumer who wants to stay informed but is forever strapped for time. On recent episodes of Up First, I've been able to get the latest updates on trade policy, the stock market, and other topics that have helped me make informed decisions. Up First is the cure you need for your news fatigue. It lets you stay informed on the top stories while allowing you to spend the rest of your day on things more productive or enjoyable. Listen now to the Up First podcast from NPR. Before I get into the details of how and why the Earth's magnetic poles will reverse, it's important to understand how geologists know that the Earth's magnetic poles have reversed in the past. Many rocks are made up of magnetic minerals, usually magnetite or the more weakly magnetic hematite, both of which are based on iron. When a rock first forms from liquid magma, the individual magnetic molecules will align themselves with the Earth's magnetic field. As the rock solidifies and cools, the individual mineral molecules are then locked into place with this particular magnetic orientation. In the late 19th and early 20th centuries, geologists began to notice that some rocks were magnetized opposite to the Earth's magnetic field. The first person to notice this was a French geologist by the name of Bernard Brun. In the 1920s, the Japanese geologist Montanori Maruyama suggested that the cause of the oppositely orientated rocks was due to the Earth's magnetic poles having been reversed. While Maruyama and Brun suspected that the Earth's poles had switched, they didn't know when it happened or how many times it had happened. The best guess was that it happened millions of years ago. In the 50s and 60s, however, there were 2 developments that helped solve this puzzle. The first of which was the development of radiometric techniques for dating rocks, which I covered in a previous episode. With these techniques, it became possible to date when most rocks were formed to a reasonable degree of accuracy. The second development was the magnetic mapping of the seafloor. This was the real breakthrough. What was discovered is that on the seafloor on either side of a mid-ocean rift are parallel and symmetric bands where the magnetic orientation of the rock would be one way and then another. For example, on the Mid-Atlantic Rift, which runs the entire length of the Atlantic Ocean, immediately on either side of the rift, the rocks are aligned with the current magnetic field of the Earth. Then, just beyond that, there's a stripe of rocks that are magnetized the other way. And then there is another stripe beyond that, etc., etc. The width of each strip is the same on either side of the rift. The reason for this is that the rift is where the tectonic plates are slowly pulling apart from each other. Liquid magma from deep in the earth comes up in the rift and then cools to form new seafloor. As this rock solidifies, the magnetic minerals inside the rock orientate themselves to the Earth's magnetic field. This process is continuous, and over millions of years, as the plate keeps moving apart, rock gets further and further away from the rift as new rock keeps forming. The magnetic stripes on the seafloor are the frozen magnetic record of what the Earth's magnetic field was like when the rocks were first formed. The current estimate is that there have been 183 magnetic pole reversals that have taken place over the last 83 million years. And that means that they occur, on average, once every 450,000 years. As the Earth is much older than 83 million years, there have been many more pole reversals than just 183. However, we don't have the evidence to identify them. While the average amount of time between pole reversals is 450,000 years, that doesn't mean that there's some sort of geomagnetic clock inside the Earth that flips the poles on some sort of schedule. It's believed to be a fundamentally random event. There is evidence of some pole reversals taking over 10 million years, and some which occurred after only a few centuries. In addition to permanent long-term changes in the Earth's magnetic field, there are also short-term changes that have been identified known as geomagnetic excursions. Geomagnetic excursions only last for a few thousand years and are associated with a weakening of the Earth's magnetic field by up to 20% and a significant change in the location of the magnetic poles by up to 45 degrees. Due to the brief geologic timescales that geomagnetic excursions occur, they're difficult to track in the deep past. However, since the last major magnetic reversal, which occurred 780,000 years ago, there are believed to have been 12 geomagnetic excursions that have taken place, the most recent having occurred about 42,000 years ago. So, if we have evidence that the Earth's magnetic poles have reversed, why does this happen? It has to do with the outer core of the Earth, which is a liquid consisting mainly of iron and nickel, both of which are magnetic. The movement of the liquid due to convection creates a dynamo which creates electric currents and hence a magnetic field. Fluid dynamics are inherently complex. So complex that when Albert Einstein's son Hans told his father he wanted to go into hydraulic engineering, he supposedly told him not to because it was too difficult. There have been computer simulations of the Earth's core which have been run for tens of thousands of simulated years, and the simulations have produced field reversals. And likewise, experiments have been run with liquid metals, and they too have shown random reversals in magnetic polarity. Basically, a liquid dynamo producing a magnetic field is much more unstable than a simple bar magnet that we might be used to. Others have theorized that pole reversals are not spontaneous events at all, but rather they're caused by something which disrupts the liquid in the core. And this could be anything from deep subduction of tectonic plates to a large meteor impact on the surface. While the evidence for magnetic pole reversals is very strong, there are still some questions that remain. The biggest one is, how long does it take for the poles to switch? There are some estimates that claim a reversal takes as long as 1,000 to 10,000 years. And there are other estimates that claim a reversal can be completed in as little as a few decades. For all we know, both of these might be possible. The fact is, we really don't know because modern humans have never experienced a pole reversal before. The other really big question is what it would be like to live through a pole reversal and how it would affect life on Earth. The Earth's magnetic field is what protects the planet from the solar wind and most cosmic rays. As these high-energy particles approach the Earth, they're deflected by the magnetic field, protecting the planet from radiation. There are some who argue that because there have been so many pole reversals throughout history, the impact to the Earth's biosphere can't possibly be that great. The major extinction events in Earth's history don't align with magnetic pole reversals. However, you will see some people who make the exact opposite argument. In particular, the demise of the Neanderthals coincided with the last geomagnetic excursions about 42,000 years ago. However, there hasn't been 183 mass extinction events in the last 83 million years, so at best, such events could only align with a few pole reversals. Moreover, even if the last geomagnetic excursion had something to do with the extinction of the Neanderthals, it clearly didn't wipe out humans. We do know that the process of a pole reversal would certainly cause disruptions. For starters, many animals, in particular birds, rely on the magnetic field of the Earth to navigate when they migrate. We aren't sure how this would affect them or how quickly they could adapt. If the magnetic field was weakened substantially, it could potentially be devastating to the ozone layer. If the ozone layer were weakened, it would result in a significant increase in ultraviolet rays reaching the surface of the planet. A weakening of the Earth's magnetic field would also cause havoc with electronics in something like a wide-scale Carrington event, which I covered in a previous episode. Many satellites, which are also protected by the Earth's magnetic field, would also be rendered inoperable. Some geologists have also speculated that after a pole reversal takes place, it could result in increased volcanism across the planet. The really big question is when the next magnetic pole reversal will happen. It certainly will happen, but we have no clue when it will happen. You will find people saying that because it happens on average every 450,000 years, and because it's been 780,000 years since the last one, we're due. However, that's basically the gambler's fallacy in action. We aren't due for a pole reversal any more than a roulette wheel is due to land on red after it landed on green 3 times in a row. That being said, there are things happening with the Earth's magnetic field right now. Since the invention of the magnetometer, which could measure magnetic fields in the 1830s, the strength of the Earth's magnetic field has decreased by about 10%. In particular, there has been a large reduction in the strength of the magnetic field in an area known as the South Atlantic Anomaly, which I have covered in a previous episode. And finally, the magnetic poles have been wandering at a dramatic rate. The magnetic North Pole now moves at a speed of about 55 kilometers per year. So something is definitely happening. But due to the chaotic nature of the magnetic dynamo in the core, it's impossible to tell if this is part of a geomagnetic excursion, the prelude to a full pole reversal, or just part of the natural fluctuations of the Earth's magnetic field. Ultimately, whatever happens, whenever it happens, how it affects the planet will depend on how long it takes and how weak the magnetic field gets during the transition. A magnetic pole reversal isn't something I would stay up at night worrying about. The Earth has been through this many times before, and even if we are in the middle of something right now, it will take decades, if not millennia, to fully play out. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oakton and Cameron Kiefer. I want to thank everyone who supports the show over on Patreon. Your support helps make this podcast possible. I'd also like to thank all the members of the Everything Everywhere community who are active on the Facebook group and the Discord server. If you'd like to join in the discussion, there are links to both in the show notes. And as always, if you leave a review or send me a boostagram, you too can have it read on the show.